Hello, wonderful people. It's Medicosis Perfectionalis. Welcome back to my physics playlist. In previous videos, we talked about an introduction to physics, how to read physics graph, how to calculate the slope, the meaning of the slope, how to determine if entities are directly proportional or inversely proportional. Then we talked about scalars versus vectors, distance versus displacement, speed versus velocity, mass versus weight. We talked about acceleration, and we talked about force. You see this F? It stands for force of attraction. Force of attraction between two bodies, such as planet Earth and its moon. G is the universal gravitational constant. The big M is the mass of the bigger object, in this case it's the Earth. The small m is the mass of the smaller object, or the moon. How about R? R is the distance between the center of the moon and the center of the Earth, from this center to that center. Take that distance and square it. This is how you can calculate the attraction force between the two bodies in newtons. Please keep in mind that the Earth is trying to pull the moon towards it, and the moon also is trying to pull the Earth towards it. Since the Earth is bigger, the Earth has a greater gravity than the moon. Therefore, the Earth is better at pulling the moon towards it compared to the moon's ability of pulling the Earth towards it. How can we know that the Earth succeeded at pulling the moon towards it? Well, we know this from the fact that the moon keeps revolving around the Earth. It does not leave its path. Thank you so much, Earth's gravity. How do we know that the moon is trying to pull the Earth towards it? From the phenomenon of the tide. Ebb and flow, ebb and flow, ebb and flow. Click the like button, click the subscribe button, and let's get started. This video is part of my physics playlist. Please try to watch these videos in order for maximum understanding and retention. Especially the last video titled Circular Motion. Please watch my video on circular motion before this one. And check out my other playlists too. Physical quantities and measuring tools and measuring units. If the physical quantity is force, the measuring tool is the spring balance, and the measuring unit is a Newton. Please recall that force is a derived physical quantity. It is derived from something else. Derived from what precisely? From mass and acceleration, because force equals mass times acceleration, according to Newton's second law of motion. How do we measure mass? What's the measuring unit? Kilogram. What's the measuring unit of acceleration? It is meters per second squared. So, if we say that force equals mass times acceleration, and if mass is measured in kilograms and acceleration is measured in meters per second squared, then we can argue that force is measured in terms of kilogram times meter per second squared, or simply 1 Newton. So 1 Newton is equivalent to kilogram times meter per second squared. Force is a vector, meaning it has a magnitude and a direction. Please recall that weight is a subtype of force. Force equals what? Mass times acceleration. And therefore, since weight is a force, it equals mass times a special type of acceleration, which is acceleration caused by gravity, small g. Please do not confuse small g with big G. Small g is acceleration caused by gravity, but big G is the universal gravitational constant. How can we define force? It's an external influence that affects an object to change its state of motion or direction. Measuring tool, spring balance. Measuring unit, Newton. There are many types of force, including contact force versus non-contact forces. Touch me, don't touch me. Today we're talking about gravitational force, which is a subtype of non-contact forces. We will not go over Newton's 3 laws of motion today because we had this in a separate video. Here I'm just reminding you that force equals mass times acceleration. Now let's talk about this. This is another force. This is the gravitational force or the attraction force between two objects, a bigger one and a smaller one, or they could have equal sizes. I don't care. How can we find F as in F me? It equals m1, which is the mass of the first, times m2, which is the mass of the second. You multiply this by g, which is the universal gravitational constant, also known as general gravitational constant. From this, we can deduce that there is a direct correlation between the mass of the objects and the attraction force between them. The greater the mass, the greater the attraction force. Also, we can see here that there is an inverse relationship between the distance between the center of those two objects and the force of attraction between them. So the greater the distance between them, the smaller the attraction force between them. Now you can simply say m1 and m2 for the mass of the first and the mass of the second, or even better, you can say big M and small m. Big M is the mass of the bigger one, and small m is the mass of the smaller one. Please remember that this gravitational attraction between the two provides the centripetal force, F sub c, required to keep the moon in orbit around the Earth. What is the centripetal force? Please refer to the previous video titled Circular Motion, where we discussed Fc in detail. But hey medicosis, where did this come from? I don't get it. What does this even mean? Well, remember when we said before in video number 1 in this playlist that if A is directly proportional to B, then we can remove this proportional sign and replace it with equal, but don't stop. Don't just say equal. It has to be equal. A constant, and then you multiply that constant by B. Now let's apply this concept to attraction force. So the attraction force is directly proportional to the mass of the bigger object. This attraction force is also directly proportional to the mass of the smaller object, which means the bigger the mass, the bigger the attraction force. Okay, this same force is inversely related to the distance between the two centers, or the centers of the two objects. So if the distance between them goes up, the attraction force goes down. If the distance between them goes down, the attraction force goes up. If the distance between Earth and Moon doubled, okay, what's going to happen to attraction force? Well, double is 2, okay? 2 squared is 4. 1 over 4 means the attraction force will become 1/4 of its original value. Conversely, if the distance between the Earth and the Moon decreased to 1/2 of its original distance, i.e. if the distance halved, therefore what's going to happen? 1/2 squared is 1/4. 1 over 1/4 is 4, so the attraction force will quadruple. So if this is Earth and this is Moon and the distance between them halved, the attraction force between them will quadruple. It will increase 4 times. Now I want you to look at these 3 facts. How can we summarize these 3 facts in one mathematical sentence? Okay, you can say that force is directly proportional to big mass times small mass over the distance between the two objects squared. And this is a very good summary. It tells you everything you need to know from the previous 3, just condensed in one formula. Okay, what if I want to remove this proportional sign and replace it with equal? You have to replace it with equal constant multiplied by this, which means that the attraction force equals a constant, whatever that constant might be, multiplied by big M, small m, over radius squared. Since we're talking about the gravitational attraction, the gravity of the Earth attracting the Moon and the gravity of the Moon trying to attract the Earth, therefore, why don't we call this the universal gravitational constant? Oh, and therefore F equals G times big M, small m over the distance between them squared. And this is where you get your formula from. Tell me more about this general or universal gravitational constant G. Well, by rearranging this equation, you can make G equals the force multiplied by the distance between the two objects squared over the mass of the big one times the mass of the small one. What's the value of this constant? 6.67 times 10 raised to the negative 11th power. And there are 2 measuring units for this. You can say Newton, because we measure force in Newton, multiplied by meter squared, because the distance is meters, squared is meter squared, divided by kilogram times kilogram is kilogram squared. Since this is downstairs, you can say over kilogram squared, or you can put it up, but change the sign of the exponent to -2 instead of 2. So this is an acceptable measuring unit. Also, you shall recall from Newton's second law of motion that force equals mass times acceleration. We measure mass in kilograms and we measure acceleration in meters per second squared. So 1 Newton is equivalent to kilogram times meter per second squared. What if we remove this Newton and replace it with all of this nonsense? Let's do it. Here is kilogram multiplied by meter per second squared, multiplied by meter squared. And let's bring this kilogram downstairs like this. Beautiful, okay? Here is kilogram squared and here is kilogram. Why don't we cancel 1 kilogram from here? From one of these 2. Okay, and then what? Meters times meter squared is meter cubed. Divided by kilogram, there you go, divided by second squared, there you go. So there is another acceptable measuring unit for the universal gravitational constant. Movement in dimensions. Driving your car back and forth is moving in 1 dimension. Look at this plane, it is flying Up and to the east, 2 dimensions. Look at this plane. It is coming towards us, that's a dimension. It is going to the left, that's another dimension. And it's descending, that's a 3rd dimension. And I've told you before that in your inner ear, you have not 1, not 2, but 3 semicircular canals to tell your brain about your position or motion in the 3 dimensions. So your brain knows if you're turning your head to the left or to the right. Your brain knows if you are ascending or descending in an elevator. And your brain knows whether you're driving forwards or backwards in a car. Now, what's the name of the cranial nerve that carries equilibrium sensation from your inner ear to the brain? If you know, comment below. Motion could be linear, back and forth, or rotational, turning left, turning right, in a path that looks like a circle or an oval shape. If you wish to see more physics videos in the future, drop down a telescope emoji in the comments, or just a car emoji. So, we have linear motion and rotational motion. Rotational could be circular, it could be orbital, like planets. Some of them have circular, others have elliptical orbits. There are also statics and torque, and these concepts should be discussed later. If the car was driving forwards and you press on the accelerator or the gas pedal, what's going to happen? You will speed up. Will this change your direction? No. Will this change your velocity? Of course, it will increase my velocity. So you will accelerate in this dimension. But what if you're driving and then you apply the brake? That's a force in an opposite direction. Will your direction change as a car? No, I'll just slow down. So your velocity decreases. What's going to happen to your acceleration? It becomes negative because you're slowing down instead of speeding up. But let's say that you decided to apply the steering wheel. Oh, so you're trying to turn to the left, for example. Did the velocity change? No. Did the direction change? Yes, it did. And therefore, this is not called linear acceleration anymore. We'll call this centripetal acceleration in a circle. Here is a problem for you. Please pause and try to answer this yourself. Okay, let's go. The mass of the sun, of course, this is the big dude, so big M equals 2 times 10 raised to the 30th power. Okay, and what's the small m? Well, Jupiter is 2 times 10 power 27. The distance between their centers is, oh, that's my R for sure, 5 times 10 raised to the 11th power in meters. Find the mutual attraction force between them. Oh, so they want F. F equals universal gravitational constant times big M times small m divided by radius squared. What is big M? They should give this to you on an exam, so it's 6.67 times 10 raised to the negative 11th power. Multiply this by the big M, or 2 times 10 power 30. Multiply this by the small m, or 2 times 10 power 27. Divide all of this by 5 times 10 power 11 and you square this. Do the math, you'll find that the attraction force equals 1.067 times 10 raised to the 24th power Newton. Alright, gravitational field. Since Moon is relatively close to the Earth, it lies inside the gravitational field of the Earth. But let's say that we have an object that's far away from the Earth. Do you think the Earth will be successful in attracting the object? The answer is no. So the gravitational field is a range of distance around the Earth. If you're inside, you're attracted to the Earth. If you're outside, you're not. So, definition of the gravitational field is the space in which the gravitational force of the Earth takes place or appear or is evident. Of course, the farther away from the Earth you go, the lower the gravitational force of the Earth on you. And this gravitational force keeps getting lower and lower and lower the further away from the Earth you go, until it disappears. Equations, you know that the weight equals mass times acceleration caused by gravity. You know that the attraction force equals g times the big mass, small mass over the distance between the centers squared. Since this is force and this is force, we can make this equal that. You can cancel the m or the mass from here and here. And before you know it, small g equals big G times big M divided by the distance between them squared. And what do you call the small g now? Gravitational field intensity. As you see, it's inversely proportional to the distance. Which means if I get far away from the Earth, the distance goes up. And the gravitational field intensity, or the ability of the Earth to attract me, goes down. Because these two entities are inversely proportional. Okay, but what is r to be specific? Is it just the radius of the Earth? No, it's the radius of the Earth only if you are right on the Earth's surface. But what if you are on top of a skyscraper? Oh, then you need to add the radius of the Earth to the height of the skyscraper. We can illustrate this like this. Here is the Earth. Here is the center of the Earth. And here is the skyscraper, and here is me on top of the skyscraper. If I want to calculate G that is affecting me, or the gravitational field intensity trying to pull me towards the Earth, I need to use this R as the radius of the Earth plus the height of the building. Okay, amazing. This is true if the building or if the thing is above the surface of the Earth. But what if I'm hiding in a cave or a mine that is deep into the abyss? Then you subtract instead of adding. Instead of r plus h, it becometh r minus h. I've told you about the measuring unit of G. The measuring unit of m is kilogram. The measuring unit of this distance is meters. When you do all of the math, you will find that the measuring unit of G either is meters per second squared or Newton per kilograms. What if we want to compare the acceleration due to gravity for two planets? Well, then here is G for the first planet and G for the second planet. I know that G, small g, equals this, and the small g equals this. So this over this. We can cancel the big G with the big G. And then we can rearrange this equation like this. So it is the mass of the first times the r for the second squared, divided by the mass of the second times the r for the first squared. And this is some crisscross action. Here is a problem for you. A mine is 500 meters deep below the Earth's surface. If the Earth's mass is this and the Earth's radius is this, find the acceleration due to gravity inside that mine. So what do we know? We know that the mine is 500 meters deep. Okay, so this is my h. Let's make it a negative 500 m because I'm deep inside, not above. The mass of this Earth is 5 times 10 power 24, and the radius of the Earth, remember, it has to be in meters. So you multiply this number by 1000, so it becomes 6360 times 10 power 3 meters. The acceleration due to gravity is small g, which equals big G times the mass of this Earth divided by r. Should I say plus or minus? Well, you can say plus a negative or minus a positive. Here is r minus h. I'm not done yet. You need to square this denominator, which equals what? G, they will give this to you, 6.67 times 10 power negative 11. Multiply this by the mass of the Earth, or 5 times 10 power 24, and divide this by r. What's the radius of the Earth, please? It is this number. We need to put it in meters like this. And don't forget to subtract what? The 500 meters of that mine. And all of this needs to be squared. And the rest is math history. And here is the answer. What's the measuring unit for the small g? Newtons divided by kilogram, or meters divided by second squared, because at the end of the day, this is an acceleration. Quick note about satellites. What is a satellite? A teacher of mine once said, a satellite is nothing more and nothing less than a rock that is thrown by a certain velocity at a certain angle, and the velocity was large enough to make the satellite orbit the Earth in a circular path. But if I dish out that satellite in a low velocity, it will hit the Earth's surface. Let's increase the velocity. Okay, I'll travel more. Then I will hit the Earth's surface. Increase the velocity. Okay, I'll travel more, and then I will hit the Earth. Let's increase the velocity. I still hit the Earth. Let's increase the velocity even more. Okay, at the sweet spot, you can actually make it a satellite. We know that force equals G times the big M, small m divided by r squared. We know from the previous video that force equals mass times velocity squared divided by r. Let's make this equal that. Cancel the mass on each side. So that velocity equals what? G times m over r, because you can cancel this r with one of these r's. If v squared equals that, then v alone equals the square root of g times m over r. What is that v? This is the orbital velocity for the satellite. Here is a question for you. The slope of this green line represents what? Please pause and try to answer this yourself. Okay, first, remember the slope of anything equals what? The change on the y-axis over the change on the x-axis. In this case, it equals v over square root of m. What does that remind you of? It reminds me of this equation, which says that v equals the square root of g times m divided by r. Let's get m out of this square root. Okay, we can do this. So here is m outside of the square root with its own root. You multiply this by big G, divide by r. If I want v divided by square root of m, okay, by dividing both sides by the square root of m, you get something like this. V divided by the square root of m equals the square root of g over r, which equals what? This equals the slope, making the correct answer choice D, as in doofus. Let's solve the problem of the previous video. The ratio of the centripetal forces acting on two bodies of equal masses when the first moves with the speed of 5 in a circle of diameter 4 and the second moves with the speed of this in a circle of diameter of this is what? Pause and try to answer this yourself. How do we do it? Well, we remember this equation from the previous video. First, you write everything that we know about the first body. Let's call it A. All right, it has the same mass as body B. So let's call this M. All right, what's the velocity for the first? 5 meters per second. And what's the diameter? 4 meters. So the radius is what? 2 meters, half of that. Okay, and for B, we know V2 is about 10 meters per second. And what's the radius? Well, if the diameter is 8, the radius is 4. Then from this equation, we will imagine a centripetal force for A and a centripetal force for B. Centripetal force equals what? mv squared over r here and mv squared over r here. This is for A, this is for B. You can cancel the m with the m, they are the same. And then do the math, you will realize that this equals 1 over 2, making half the correct answer. Again, D as in doofus. And here is your homework. Please pause and try to solve this yourself. Let me know your answers in the comment. You'll find the answer key in the next video in this glorious physics playlist. You can download all of my physics notes, general chemistry notes, biochemistry notes, organic chemistry notes on my website medicosisperfectionalis.com. Make sure to check out my other playlists as well. If you found this video to be helpful, please support the channel by buying me a coffee. Go to buymeacoffee.com/medicosis. Learn about how your kidney works, what happens in the proximal tubule, loop of Henle, distal tubule, collecting ducts, etc. by downloading my kidney physiology course at medicosisperfectionalis.com. It comes with videos, notes, and cases. There are more than 600 premium videos available on this channel when you click the join button and choose the highest tier. Please subscribe, hit the bell, smash like, support my channel on Patreon, PayPal, or Venmo. Go to my website to download my courses, notes, and cases, or if you would like me to personally tutor you. Be safe, stay happy, study hard. This is Medicosis Perfectionalis, where medicine makes perfect sense.